Hello, welcome back to Mathing channel. Today we'll be talking about homogeneous differential equations and how to solve them. How do we know them and how to solve them? Firstly, you must know that any dE of the form dy dx equal to the function of y over x is what we call an homogeneous differential equation. So how do we solve this? We bring in a variable v, let's say v, such that y is equal to v times x. Now we are saying v is a function of x, since y is a function of x, so v is a function of x. So using our product rule, we get dy dx to be equal to v plus x dv dx, because we already said v is a function of x. Alright, so let's solve the question. X squared plus y squared over xy. Now the first thing to notice is this dE, is it an homogeneous differential equation? So let's see. I can write this one here in what form? I have dy dx equal to x squared divided by x gives me x. I have x over y plus y over x. I can write this as y over x raised to power minus 1 plus y over x. So my dy dx is equal to a function of y over x. So this is an homogeneous differential equation. So let's solve it properly. We are saying y is equal to v times x, where v is a function of x, so that dy dx becomes v plus x dv dx. So anywhere I see y, I'll be bringing in v times x. Anywhere I see dy dx, I'll be bringing in v plus x dv dx. So let's go. I have our question back. Dy dx equal to x squared plus y squared over xy. So I said our dy dx is v plus x dv dx. So v plus x dv dx equal to x squared plus vx raised to power 2 over x vx. So let's simplify. X dv dx becomes x squared plus v squared x squared over vx squared, okay, minus v, minus this v here, goes to the other side. X dv dx becomes 1 over v plus v plus v. X squared divided by x squared becomes 1 over v. V squared removes 1 v here, I have 1 v left. X squared, that's v. So minus v. So I left with x dv dx equal to 1 over v. Now I can see that this is a dE that is variable separable. I can separate all v from x. So we have v dv equal to dx over x. I'm bringing v up here, multiply by v, then bring x downwards. So you have v times dv equal to dx will come up, dx over x. Now I can integrate both sides. So we have integral v dv equal to integral dx over x. This gives us v squared over 2 equal to ln x. Now I need a constant of integration plus, let's say, ln c. Now why am I using ln c? Because log of a constant gives me a constant, so I can easily multiply the two of them and have ln cx. Okay, v squared over 2 equal to ln cx. Now recall, we said our y is v times x, so our v becomes y over x. Okay, so I'll come back here and I have y over x raised to power 2 times 1 over 2 equal to ln c times x. So y squared over x squared times 1 over 2 equal to ln cx. So our y squared becomes 2x squared ln cx. So this is the solution of our differential equation. Let's look at another question. Now it is important to check, is it really homogeneous? So let's check. Y x minus y over x squared can be written as y over x minus y over x raised to power 2. So this is a function of y over x. So this is a function of y over x. So basically this is an homogeneous differential equation. So I would say let y be equal to v times x, so that dy dx becomes v plus x dv over dx. So our question becomes v plus x dv over dx equal to, we have y up here, we said our y is vx, that's v times x minus v times x over x squared. So let's simplify now. V plus x dv over dx is equal to v minus v squared, v minus v squared. You should expand by yourself and see what we are talking about. Vx times x is vx squared over x squared, you have v left. Vx times vx, that's v squared x squared over x squared, you have v squared left. So our v here can come to this side. You have x dv over dx equal to v minus v squared minus v. So x dv over dx is minus v squared. And this is variable separable. Variable separable. What do? We separate all v from all x. So we have minus dv over v squared equal to dx over x. Dx over x. So I can say this is v raised to power minus 2 dv equal to minus dx over x. Now integrating both sides, integral v raised to power minus 2 dv equal to minus integral dx over x. This gives us v raised to power minus 1 over minus 1, and it is equal to minus ln x, say minus ln c, because it's a constant. Minus 1 over v in this place, this one gives us 1 over v, is equal to minus ln c times x. Logarithm. I'm factorizing minus, so you have minus ln c plus ln x, and you have ln cx. So our minus here can go away with this minus. We have 1 over v equal to ln cx. Your v becomes 1 over ln cx. Now recall that we said y equal to v times x, so our v will be y over x. That means our solution was v equal to 1 over ln c times x will be y over x equal to 1 over ln c times x. So your y becomes x over ln cx.